Hello, friends. Welcome to Nexus, a smart buildings technology podcast for smart humans. I'm your host, James Dice. If we haven't met before, I write a weekly newsletter on this same topic. It's also called Nexus. Each week, I share what I've learned, my opinions, and what I'm excited about in the quickly evolving world of intelligent buildings. Readers have called Nexus the best way to stay up to date on the future of this industry without all the marketing fluff. You can check it out and subscribe at nexus.substack.com or click the link in the show notes. Since starting the Nexus newsletter, many of you have reached out to me wanting to talk shop, and we have. After a few weeks of those wonderful conversations, I realized I needed to record and share them with our growing community. So here we are. The Nexus podcast is born. This is our chance to explore and learn with the brightest in our industry together. Episode 29 is a conversation with Trevor Sodorff of DB Engineering and Keith Berkoben, software engineer at Google. These are two of the people responsible for rolling out the Smart Buildings program worldwide at Google. We talked about many of the topics we've been covering for a while here on the podcast, like analytics, data modeling, and supervisory control. But this conversation was about doing all of that at scale, doing it worldwide, doing it on new buildings. So how is Google doing that? And it's pretty impressive. Of course, we covered the digital buildings ontology effort as well, where the team is trying to make a lot of their data modeling work public so others can take advantage of it. All right, Keith and Trevor, welcome to the Nexus podcast. I'll start with you, Keith. Can you introduce yourself for us?
Sure. My name is Keith Berkoben. I'm a staff software engineer at Google, and I'm responsible for building out our internal smart buildings platform and doing a lot of the work related to modeling our buildings so that we can write software that's portable across our fleet.
All right, we're going to nerd out about that topic. Trevor, how about you? Can you introduce yourself now?
Sure. My name is Trevor Sodorff. I'm the director of engineering analytics for a company called DB Engineering. We're located in Redmond, Washington, and we do smart building consulting for Fortune 50 companies and governments around the world. Google happens to be one of our clients, and my specialty is in the acquisition, organization, utilization of data at scale. And that's my primary focus.
Cool. All right, Keith, so back to you. I want to hear how you got to smart buildings. So you're working in smart buildings now. I bet you didn't start out thinking, man, I'm going to make buildings smarter when you started out your career. So how'd you get here?
You know, I think the thing that was really interesting about how I got here is that I did this like junior year group engineering project in college that was like optimizing a HVAC system for one of the buildings on campus. And I was like, oh, this is kind of neat, but never like thought anything of it. And then realized, 10 years later, holy crap, this is my job. So that was sort of odd. I fell into this, I think, because I've always done a lot of different types of engineering. So, building stuff, software engineering, mechanical things. And so I immediately felt comfortable bridging this gap between these mechanical systems and all these things in the building and the building trades and things like that and software. And so it was just kind of a natural fit.
Great. I love that phrase, bridging this gap. That's kind of what Nexus is all about. How about you, Trevor?
I studied mechanical engineering in college. I went to Washington State University where they specialize in manufacturing processes, which I really didn't like. I got on with a firm in Redmond called DB Engineering, and that's where I currently am. And I was doing a lot of energy optimization for buildings in the kind of conventional retro commissioning process where, you step into a building, you look at the BMS, you look for fan coils that have failed chilled water valves or air handlers that are running too often. And one of my primary responsibilities was quantifying those, right? As you have to if you're doing like utility rebates. Mm-hmm. And so I spent a lot of time doing that, pulling data, organizing it. And I found that, a lot of these things are something that you could replicate multiple times. I'd end up doing the same analysis over and over again. And it was kind of, became a pain after a while. At the same time, I was working doing this for one of my clients who happened to be Microsoft, and they were really interested back in 2011, 2012 in getting into the smart building space because it wasn't really a thing at the time, but you wanted to be able to integrate all that data. They understood the value of the data. And so I was involved with helping them to implement that platform, organize their data, and then write fault detection around it. And so I was able to kind of dip my toes into the mechanical waters and into the software side. And I mean, as I found out going through the mechanical systems, they kind of suck. The whole industry is, especially at that time, it was a little bit backward, right? Everything's proprietary, locked down in its box, and that always just drove me insane. Mm-hmm. And so as Microsoft started to expand that, spent a lot of time working on, advanced fault detection, other analytics that we wanted to do at scale, help them do a bunch of projects around the world for themselves and for other customers. Got involved at Google when one of the directors at Microsoft moved down there and started working on that campus. Okay. And that's where I met Keith. I saw that they were trying to go down the same sort of path, but using more of a homegrown technology as opposed to like an off-the-shelf product like you might get with like a Switch, a SkySpark, an Iconics, or whatever. Okay. And I thought that was interesting.
Okay. That sounds about like something Google would do. All right. Before we get into that, the last 10 episodes or so, I've been asking this question, which is my favorite question of the podcast, which is, why is technology in our buildings, decades behind other industries? So Keith, I'll start with you. What's your perspective coming from the outside?
Can I just defer that question to Trevor? I think the physical buildings just last for a long time, right? And there's, all of the incentives around how you finance buildings and how you build them and maintain them discourages you from replacing stuff that's already there. And so as a result, you built a building 25 years ago and the stuff you put in there is still there.
Totally. Yeah. All right. That's a simple answer. What about you, Trevor?
Yeah. I mean, they're starting to do this more and more today, but back when I started, the idea is that you're kind of, as a building owner, you're locked in with a manufacturer, a group of manufacturers, basically for the life of the building or for the life cycle of the BMS. And you were kind of stuck with their shortcomings. The concept of interoperability really wasn't there. Yeah. And we're starting to see that progress pretty heavily in the tech space, but because of, I think, the business models of a lot of the legacy, controls providers, mechanical providers and stuff like that, it's like they want to lock you into their box. And I mean, it's not the direction that we want to go over the next 10, 20 years. And it's a big ship to try and steer, right?
Mm-hmm. I can feel your frustration because you and I have a very similar career path and basically starting with energy, becoming mechanical systems kind of experts, and then getting into software and then realizing that basically the data is not free. I mean, that's the main piece of it when it comes to energy engineering. You need the data to optimize a system, to analyze it, and the data is not free. And the word that Andrew Rogers used is probably like 7 or 8 episodes ago on the podcast was he said, building owners are not able to self-actualize. And I love that phrase as far as like, I'm trying to do stuff in my existing systems and existing vendors, usually because of their business models, like you're saying, are sort of not letting us progress the way we want to progress.
And I wouldn't say that it's all like malevolent or
no.
Like some of it's just technology is old, right? Mm-hmm. Like I've been working with one client trying to integrate systems that are 20, 30 years old. And, just how can you possibly do it? The available data that even the underlying systems has, like a lot of it's a technology problem as much as it is like a
business model problem,
motivation.
Mm-hmm.
Yeah.
The thing you made me think of actually is EMRs, electronic medical records, or even like airline reservation systems is another great example. And when you have a huge ecosystem with embedded technology or entrenched technology of significant complexity, it always ends up being easier to be backwards compatible than it is to try to migrate the thing that already exists. And so what you end up is you have like these core aspects of the way these systems work, BACnet being a great example, right? That are, I don't know exactly how old BACnet is. Maybe it's 40 years old. It's not a young protocol, right? Is still endemic to the industry because it's just been backwards compatible, systems that have been added for years and years and years. And that is just the nature of something where you have physical infrastructure that you have to deal with.
And how does that show up with, like, just for the people that are new to technology, kind of like me, how does that show up with electronic medical records?
Oh, well, it's that you have all of these hospitals that have huge systems to deal with all these records. And, if you as a technology vendor come in with something new and it's not backwards compatible with what they already have, it's immediately a non-starter because no one wants to invest in upgrading the system that they spent a bunch of money on that they already have.
Yeah.
And so you see that the airline industry is just now moving past systems that are, from the 70s or maybe even earlier. And similarly with EMRs, it's very hard to get onto modern platforms because no one wants to invest in migrating.
Totally. It's fascinating how these parallels happen in these industry silos. All right, let's start talking about Google then. So we're talking about smart buildings today, but let's start by kind of putting that in context in this overall, like, what is Google trying to do? And specifically, I want to ask about, I had this really cool article in the newsletter, I don't know, 4 months ago, where it was talking about how Google's shifting data center loads across the world in real time to basically match up the loads with the cleanest power at that time as a strategy to get to some sort of carbon neutrality or, positivity at some point, right? So can you kind of paint us where this fits in the context of Google's strategy, Keith?
So there's a couple aspects to it. And actually the carbon one is, kind of new in a way. The bigger one is that Google operates at such a scale that we're often the largest customer of any given system in any domain, whether it's, a physical security system or a, HVAC head end or, et cetera, et cetera, et cetera, right? To the point where we start breaking these things. And scale really is, with traditional approaches, oftentimes a barrier. And the whole goal of what we're trying to do in the smart buildings world is to turn that on its head and use the scale to our advantage rather than have it hold us back. And then, of course, recently with our, newly announced initiative to be, zero carbon by, I've forgotten the year now, right? Now, not only is this kind of a philosophical thing where like we would like to be able to build applications that scale for our buildings, but now we really have a very strong incentive, to deliver something very specific with those applications, which is energy savings.
So let's talk about this breaking systems. Tell me a story about this. So how many buildings do you guys have on a given campus?
On a given camp? Well, I mean, so I think in the Bay Area, we have over 100 buildings. I don't know what the exact number is, and I probably couldn't tell you even if I did.
Picturing like a Siemens to Sego or like a Johnson Medicis, and you plug in 100 buildings to that, and you're saying it's just the scale of like these.
Well, I mean, so the fact is that we don't even try, right? I think that, for the Bay Area, we are running, I don't know, Trevor probably knows the exact number, but certainly more than a dozen separate web control instances for HVAC. Because simply they would blow up if you tried to do anything else, right? And so that kind of thing gets really bothersome when you have hundreds of buildings globally.
Got it. All right.
Plus new construction. That's the other thing, is that Google's growing at the same time this is happening. We're not talking about like a company that's kind of at stasis and it's just the same campuses being maintained. They're doing a lot of growth. And so, we're dealing not just with existing legacy buildings and legacy systems, but we're also dealing with net new buildings and processes around those, with BIM and with, different IoT style approaches. Right. I don't know if you want to talk at all about IoT light versus IoT heavy, Keith, and as part of what you guys are doing, but like there's just the different philosophies and they're all kind of there at the same time.
Okay. Before we dive into that piece, just help me understand how Google operates buildings. Like, do you guys have your own separate facility management group, or you hire that out, or how does that show up?
It depends where regionally. We are big enough that there isn't one answer. In the Bay Area, we try to centralize it. So we have a central operations center that fields all of the issues and has big screens on the wall and such like. And we contract out a lot of the actual operations work to various companies.
Okay.
But it varies because we have sites, some places in the world where you have, one building in a country And then you have other places like the Bay Area where we have, over 100 buildings in a region. And so part of what we're thinking about is, well, how do you homogenize the way you deal with that, even though you have such big structural differences? And I'm not sure we exactly have the answer yet, but it's something that we're thinking about.
Yeah. So basically the impetus for this, do you call it the Digital Buildings Project? Is that what you call it?
Yes.
So the impetus
for
this,
that's the GitHub project anyway.
Got it. Okay. All right. Well, that's good enough for me. So the impetus for this is basically we've realized we have all this diversity of systems. All of these systems can't really handle our scale. We have different ways of operating worldwide. So what's the solution? Like, where are you guys headed, given all of that and given your goals?
So my opinion, and I think Trevor probably shares this opinion, is that there are a few high value things that you want to do in your building, and that you can build, a supervisory control apparatus that allows you to do those things the same way in every site. And that captures a huge amount of the value of your building systems and all this data that you're getting without requiring you to deal with all of the complexity and all the differences of all the things across all of the buildings. And so that really, in my mind, is the strategy, is basically how do you make it so that this high value thing that you care about, whether it's your air handler, supplier temperature reset, or occupancy-based control of whether or not you're running a system in a particular place, can be done the same way across the entire fleet. And when you turn on a new building, all of those features and all of those, analytics that you have for all the other buildings just work in this new building. That's the holy grail.
I love it. And Trevor, the reason I'm so excited about what he just said is like our history as energy engineers turned analytics professionals, right? The progression that everyone gets to when they head in that direction is that, I'm doing a bunch of stuff that could be automated, like you said earlier. I'm doing it over and over again in spreadsheets and hobo meters and things like that, right? And then you go into, okay, now I'm going to put analytics on top. I'm going to do some analytics. And then the very next question then is, okay, analytics discovered, like Keith just said, a supplier temperature that is not resetting and it should be. Okay, well now I have to go talk to that vendor and convince them why they need to do the reset and basically pay them or figure out if a service contract covers their time. And then they say it's done and then it's not done. And then I have to go through the entire thing again. So how are you seeing this in terms of helping this sort of supervisory control get implemented, throughout the world?
Well, so I think we want to talk about two pieces of this problem. One is the end use, which is a kind of a problem everywhere. And one is how you get to that end use. So like with Google, what they've been doing, they have a lot of control over their own systems. It's not like they're at the behest of like manufacturers for a lot of these things. They have their own controls group in-house, and they partially subcontract. My team will, with the data that comes out of the Carson system, which is part of the BOSS system, which is the overarching thing that Keith is kind of referring to with their strategy. We take that data, we'll build like dashboards or analytics on top of that using their base data. And then those are just automatically updated, refreshed as the data comes in. And we'll have engineers both with my team or with other people around the world that are using it, or with, HVAC techs or whoever's looking at this, they'll be able to use and interact with it and make the changes. And we do training to try and help them understand why they should care about these things. Google has a pretty good handle on how they deal with that. And they're really good about like not making everyone's responsibility like fault rules, right?
Mm-hmm.
Like one of the things I've seen done elsewhere is, all the HVAC techs are responsible for their quota of faults that they have to get fixed in a month. And that tends to not be very efficacious because like they don't care. They have other motivations. Hot cold calls being one of them, right? And so if it doesn't reduce the amount of hot cold calls they have, they don't really care. It's kind of a waste of their time. You're better off having a strategic group that is responsible for these things, that has the tools available to be monitoring these things, or in an ideal case, a system that can automatically respond and posture the system or adjust, which is something that we're building towards with Google. But the piece that underlies all of this is the structure and content of the data.
And I don't mean just in terms of what data is available, like, oh, the air handler has a static pressure and a static pressure set point and a VFD speed, right? It's also in, I've got this air handler that has a fan wall and it's got effectively 2 or 4 fans versus this one with 1 fan. Are those analogous? Mm-hmm. And how do I teach a machine or encode into a machine that these 2 things are analogous and that I can treat the analysis or the response the same? That piece of it is something that requires some rigor. Right. Totally. You can't just like supply fan 1, supply fan, like there has to be some underlying meaning to supply fan versus discharge fan versus exhaust fan, like give it some sort of contextual meaning. And so what we realized as we started rolling this out is that the use cases are there and the scalability in terms of connection is there, but the scalability in terms of organization and the robustness of that organization is the thing that is really at the heart of the problem that the industry sees today. In my opinion, right? Like I hate organizing data. I really hate it. But I know that if we don't organize it properly using best practices, then you're going to regret it and you're not going to get the use out of the system that you thought you would. And
you can't enable what Keith just described, which is I'm trying to set a new control standard throughout my entire portfolio. And you can't enable that unless all of the systems are modeled properly. So you know which sequences apply to which systems and that kind of thing. So I want to pause on the modeling question because I know we're about to get into that. Just pause on that real quick. So when you're thinking about rolling this out though, paint the roadmap for me. So what I'm picturing is we're getting all the data together and then what? And I think what I'm hearing though is you're going from the data's together, I'm going to model it somehow. We'll get to that in detail in a second. Then you're adding visualization analytics onto it. And at some point you're adding supervisory control as well. So paint to me like how you guys are like rolling that out. And if that's not the correct progression, correct me, you know?
Well, so the analytics in that piece are really somewhat independent of the rollout because like the use cases are going to vary from region to region. And we've got a lot of use cases built and in production in the Bay Area. And as we start to roll this out globally, like they tend to be a little bit different. And so that piece of it is, I think, a little more straightforward because you know what you'd want to do with the data if you're a facility manager in the UK or in Singapore or wherever, if you had it. And so the real question is, how do we get it? And that is the piece that Keith and I have really been focusing on. Because we know that's the hardest part. Like that's the most manual, human reliant part. Everything else after that is gravy, right? Like you can roll out a new application or a new analytics component once you have that. So how do we enable people to apply a model that's good, rigorous, and in the format that we want? And they don't have to have a lot of information about the underlying ontology in order to do it. Like they don't have to have as much familiarity. And so the way that we're approaching it, I think globally, and Keith can talk to this, is we're trying to enable MSIs around the world that are working with Google to perform their new construction or their TI projects or whatever. We're trying to enable them with tooling and with this project and with processes defined as part of that project to ease the project so that they understand up front, like these are the types of systems that we want to integrate. They have whatever they do to integrate them, if it's a JACE or whatever it is. And we give them a format, like a template for what we want the ultimate model to be in. And we provide tooling through our project that validates that. Any extensions that they want to make to the model or any instances of the model that they want to give us as part of like the final delivery handoff for that project. And we can talk about that in more detail, but in my mind, like the analytics piece is everyone in the world knows about analytics, kind of how to do analytics, how to scale analytics. It's the piece in front. Like how do you get a system to have that organized data? How do you have a model that gives you something that you can then extend on top of?
Yeah, totally. Let's dig into that piece. So it sounds like the major thrust of the project, if we could call it that, it's a bunch of projects that are happening together, is just getting systems online, getting the data flowing, freeing it up, using local MSIs to do that in a standardized way. Yeah,
that is the goal. And we can talk about this a little bit because it's not been all like, flowery goodness. There have been some hangups to it. And part of what we want to be extending our project to do in the near future is to help reduce the friction associated with this more rigorous model. And, a lot of the flack that we get for this project is like, well, there's brick and there's haystack and, I think Siemens has one. Like, why aren't we just using one of those? Well, part of that is because there are things that we want to be able to do and support that aren't fully supported within those models. And there's, in our opinion, not adequate tooling around the enforcement of extension of those models. And Keith, I mean, this is your area. Maybe this is something you want to blow up
Well, let me
about.
kind of just set the stage for someone that doesn't have that context of why you said what you just said, which is you realized, okay, I have all this data worldwide. I'm going to get it into some centralized location. I know I want to be able to do cool stuff with it later on, but right now this data has no meaning. And what I heard you just say is you looked at all the other efforts to produce meaning in our industry, which is Haystack and Brick, and there's probably several other worldwide that people are like, well, why didn't you use our standard, right? So Keith, when you looked at that, what did you find? What did you do? I guess it'd be a good time to say what the project is for the first time.
Okay, well, yeah. So actually, I think the first thing that's kind of relevant is what my context was when I came in, right? So I'm a software engineer, and up until I started working on this, while I had some, kind of general experience in like what building systems are and roughly the things that they do, I had no experience as like an MSI or actually working in the building industry. And so I came into all of this stuff completely naive. And I was like, okay, we need to model this stuff because I understand, generally how you write software. You need an abstraction layer to do stuff. And I was like, okay, I got to find this abstraction layer. And I looked at Haystack and Brick at the time, and the gap for me was usability, right? Like, as somebody who didn't know anything about this, who didn't have any available tooling, who needed to do something quickly with rigor, those platforms just didn't offer what I needed. Like, they were either, they didn't have coverage in the right places or had too much coverage in another place, and they weren't opinionated enough that I could do something with them that was functional quickly.
There's a lot of good terms here. I'll let you keep going, but I want to circle back
and so right. And so coming into this, I was like, okay, well, I have this very specific use case, which is that I want to enable supervisory control and analytics at scale. And I need something that makes that easy for me to do. And part of the art of modeling is being opinionated about something in a way that makes it easier to get to your ultimate application goal. Because if you try to model the entire world, and there are places, companies who have tried this. I think there was this really great IBM effort to like create an ontology of everything at one point. And it's just like very quickly becomes so unwieldy that you can't do anything with it. And so you have to be very careful about shaping your model to really map to your application and what you need. And so we decided to build something because we were like, we want something that helps the user to get to that thing that enables the supervisory control and analysis quickly, and make it so it's hard for them to make mistakes. And so that's kind of how we got to where we are today.
And I feel like this is a missing piece of the sort of ontology or data modeling conversation in our industry. So Nick Gajewski from KGS Buildings and I talked about this on, I think it was episode 3, but his perspective is that he's seen a lot of people say, like, quote unquote, tag data, and then the myth, I guess, in the industry is that now that the data is tagged, I can do anything I want with it, right? But the thing that people find out is then when I go try to do a slightly more advanced use case, right, like supervisory control, which is an extremely advanced use case, you're then finding, oh, I didn't quite tag it in a way that enabled that to happen, right? So is that what you mean by opinionated, or what do you mean by that?
Well, sure. So opinionated in the sense that you have to decide what things you care about representing from the real world in your abstract model. So as an example, maybe if I only care about high-level supervisory control, because that seems to be our meme in this podcast, right? Maybe I don't need to model a PID loop for a VAV damper, because I just don't care, right? The only thing I'm ever going to change is the set point. And so building a model that lets me do that doesn't necessarily have any value. I mean, I don't think we've had a decision about whether or not we're going to model PID loops, but the point being that if the thing you're trying to do doesn't need a certain piece of complexity, then the opinionation of the model is to basically erase that complexity from the world so that you just don't have to deal with it. And you have to be careful about what you erase and what you don't.
I would like to talk explicitly about some of the things that were missing from Brick or from Haystack.
I was just going to ask that.
Because I want to give concrete examples. And maybe timeline real quick. Keith and I started collaborating on this, I want to say like a year and a half, 2 years ago on this specific thing. And at the time, there were a couple of drawbacks with both Haystack and with Brick that we didn't see a workaround for without kind of doing some hodgepodge mixture between the two. The thing that was missing from Haystack, we thought at the time, was a little bit of the rigor around definition and the lack of relationships. Most of that's solved in Haystack 4. Like, they're doing a good job with improving the platform, but at the time, like, that was a big piece that was missing. The ability to natively within that tagging structure build in relationships, because that's a core component of what we need in order to be able to do any sort of system control, right? On the converse side, Brick at the time was sort of a new thing, and it had the concepts of, relationships and entities and these things built into it natively. That was missing around it was any sort of extension of available. They're not really tag sets, but you could imagine like standard field names.
Okay.
So it's like, well, if we're going to adopt this one, we're basically going to build it all for them. Plus, and Keith, you might give some additional content here on why Brick, like, we modeled ours after Brick, but we extended Brick. Keith, you want to chat about that a little bit, or leave it at that?
Yeah, I mean, so I think the thing that we did I don't want to say better, but that we invested more effort in than these other aspects was the idea of modeling above the level of points and giving real structure to equipment and composable functionality.
Love that. Opinionation and tooling and composable functionality. Like, we're going to need a glossary for this episode. But yeah, so what do you mean by that?
So as an example, and I'm a little bit fuzzy on the details now because I haven't looked in a while, but, Brick, as an example, was really atomic down to like the point. It was a pure graph, right? Like, your piece of equipment in the model was, a bunch of connections between these point entities that made up a piece of equipment, because it basically was RDF, right? And for our purposes, that was too low level, because the amount of complexity you needed to like build up a logical piece of equipment that you cared about was really high. And so we kind of jumped up one step higher and said, okay, well, we want this concept of a piece of equipment we logically understand, an air handler, a fan coil unit, a VAV, et cetera. And we want to make it easy to build one of those and model it. And so we sort of focused more around this idea of equipment and equipment with functionalities where you could define a piece of functionality. So like, damper control based on a temperature or something. And you could then say, I have a piece of equipment and it has this functionality. And this functionality then requires that you define these points for that functionality, because that's what you need to analyze that functionality. Okay. And so then through composition of these things and inheritance, you can now very rigorously construct things that you can deal with programmatically.
So if I build on our meme here and I want to say, implement static pressure control on all of the fans that can possibly do that worldwide, that's kind of the approach you're saying, is like, anywhere I have a VFD on a supply fan, VAV boxes downstream, and a discharge pressure sensor, now that component, and this is just an example that might not be quite accurate, but like that component is now able to be pushed out, and now I can standardize that sequence as long as those components are there, basically.
Yeah,
exactly.
And so our idea was that a fan coil is not equivalent to the sum total of its available points. It's equivalent to its sum total of composed functionality.
Yeah.
And so say that I've got like fan control, it's going to have a start stop and it's going to have like a status feedback, maybe some feedback for the amperage or for something like that. That becomes one chunk, one composable piece. Then I've got, it does zone temperature control with dual set points, a heating and a cooling set point, and it uses that to control the chilled water element. That becomes one piece. The dual set point control can also be its own piece, and you can compose it of these kind of overlapping chunks such that you end up with the full list of required data fields, whether they're optional or required or whatever, but you can essentially compose devices more quickly by just having a basic understanding of chunks of functionality that are reusable across fans, fan coils, air handlers, chillers, whatever. That was kind of our idea, and we've implemented that. The other thing that we've kind of found was missing through some of these other projects was a large body of precedent. Yes. So, and you know this, right? Like with Haystack, two MSIs in two different places can have two different tag sets for the same thing, right? Yep. It's very common. And so one of the things that we wanted to do as part of our project was all of the things that we're actually applying to existing pieces of equipment, we're going to make that part of the ontology and part of the model documents so that like you have these templated things that we've seen before so that you can get an idea for like, maybe I have this fan coil with, the discharge VFD speed control and whatever else associated with it, and I can just take it or extend it. So that was kind of our core concept there was build a body of precedent that we can give to people and that they can kind of get an idea for what we're doing. And we have names associated with tags. Like you can imagine tag sets and like what we call standard field names as being equivalent. And we just define those and we have different contexts for where we apply them differently. And it's all just embedded there.
Got it. Yeah, this is something that I think it was episode 11, Corey Moseman, who works at NREL, is working on these similar concepts day in and day out. We talked about some of these limitations. If anyone wants to go dig back into that episode that hasn't listened to it yet, we talked about a lot of these sort of aspects. What did you guys mean by, I think I understand that concept, which is just like, let's give people examples of if they come across this fan coil, how should we do that next time, right? What are some examples, similar examples around this tooling concept? So you mentioned I have an MSI in the UK, right? And I want to make sure that they're basically setting this building up in the right way according to the standard. What do you mean by tooling and how do you sort of support that MSI in setting up that building? And caveat to that question though, is it just struck me as like how massive you guys are in terms of scale is a great thing if you're thinking about this in this way for our industry, right? So you're basically saying, we have 10 million air handlers and we're going to just basically model out all of those, right, in a standardized way for everyone to sort of benefit from, which is a difference with like at least Haystack, which is the one I'm most familiar with, right? You just said it, Trevor, is like one MSI is going to do it their way and that's their sort of version of Haystack. And that's probably going to be their little thing that no one else gets to benefit from in most cases, right? Yeah.
So I'm going to kind of discuss some of the more conceptual aspects of it, and then Trevor can talk a lot about the actual process because he's actually done hundreds of buildings now. So a couple of the things that we're missing, I think, in the other ontologies that we have both methods and tooling for are both dimensional units, which was a really big thing if you're going to actually do this, especially across the world, we have multiple units. And also the idea that standardization needs to happen in the data path, right? Because one of the things that doesn't scale is enforcing that every piece of equipment exactly models your current data model on the device. And so a lot of the tooling that we built was structure around things like dimensional units and validation to make sure that when you bring that stuff into the model, you do it consistently, but also all of the tooling to get from your native device and its payload into the model. So we have the ability to effectively configure a building and define all of the translations between what we're actually getting out of the building and what we want it to look like, and have that all happen in stream as the data is flowing.
So let me break that down a little bit because that's pretty high level. There are three things that we kind of anticipate wanting tooling for, and we're currently doing two of them.
Okay.
The first thing is, how do I apply the model and know that it's like a correct implementation of the model? So I have an MSI in Europe that is trying to build me this, effectively it's an RDF model, right? It's in YAML, but we have the ability to convert it. So trivial difference, right? But like this human readable model, I want them to construct it. They need to be able to construct it based on things that are already defined in the ontology today. Once they're done with it, it gives me a translation between air handler 1, 2, 3 with all of its different goofy available data points that map correctly by dimensional units and by direct one-to-one mapping to something that exists in our ontology into a type that exists in our ontology. When you start to do that, like, how do you make sure that what they gave you was valid? Are all the relationships between the air handlers and the VAVs correctly defined? Are they using the relationships consistently? Well, you need tooling to help you with that because no human is going to be able to do that. So we built that tooling. The second piece, because we have not seen everything that there is to see in the world, obviously we've only been doing this for a couple of years and have really focused on the US and part of Europe, we know that there are going to need to be extensions to our ontology. We're going to need to add new concepts like, certain types of alarms that are wonky in Europe or different types of control strategies. I don't think we looked at a chilled beam yet. We haven't looked at commercial refrigeration, and we want to add these things as we go. How do I ensure that when I do an update to the ontology that doesn't break something that already existed or is incongruous with something we've already done? So again, you need some tooling. And so what we've done is we've built this tooling that helps us to enforce the rigor of the model when you go to extend it. The third piece, and this is the thing that we have not developed yet, but that Keith and I have been arguing about and trying to figure out how we're going to tackle this one. We've got some POCs in place, but this is the place where we really want to focus, I think, in the upcoming years is how do I automate the application of the model? Because I've got this air handler, say I've got this CSV data dump from the system. How do I convert that into this YAML file that effectively gets converted into my translation hierarchy or whatever? Today, there's a series of things that are out there, like Brick has plastering that repo. I don't know if you've seen that, to do some like automated ML-based alignment. A lot of different people have their own proprietary things, and MSIs will tend to have some mix of manual and automated, like tagging or whatever. Niagara, I think, has this built in, but there's no overarching like available tool set that's robust enough that MSIs can use it, and that's also free. This is kind of like part of the secret sauce that MSIs have, and
to cut down the integration labor.
Yeah, exactly. And frankly, I hate that that's not something that we as an industry have tried to impact more openly, because like you can imagine that when you are doing mechanical designs, these systems are coming about, due to the heterogeneity of engineering conditions.
Yeah.
And so the engineers aren't limited in terms of the wonky, stupid stuff that they can be putting in any building and anywhere in the world. And so you have to be flexible in your ability to interpret it, right? Mm-hmm. And frankly, the whole idea of mapping this data is a waste of time to me. Like, it should be done by a machine. And my goal is, particularly with regard to this, and also with FDD and some of these other things that we kind of sometimes do by hand, is to automate it away. I want no one in the world in 10 years from now to have to build a load sheet or a spreadsheet that maps from one to one. I hate it. Mm-hmm. And so that's one of the things that we're going to be focusing on in the near future, because that's the missing piece, right?
Love it. Okay, so I sort of have the picture for how this ontology came to be, right? And so I have two kind of, I think they're related questions in that, okay, so now you guys have open sourced all the work you've done, right? It's all on GitHub. So the questions I have are around, okay, we've been using our use case of supervisory control as an example. What happens if there's some other use case that you guys don't use, that someone else that wants to use this new standard, they want to use it, right? But the model doesn't enable that. How are you thinking about that? And if you're not worrying about it, that's certainly okay too. I'm just wondering how, if I'm a new organization and wants to just take advantage of the work you've done, but I have this use case over here that you guys aren't doing, how does that work?
So I guess it depends what your use case requires that doesn't exist already. We definitely are interested in suggestions for improvements and extensions. So, I'm sure we haven't thought of everything. And there are definitely some things that we've thought of that we haven't had time to implement. So there's kind of that route is like, maybe there's a core aspect to what we're doing that like needs to be added. And, there's a collaboration that needs to happen there.
Mm-hmm.
The other thing that could easily done, if we're just talking about model coverage, right? Because I'm sure that there's a gajillion pieces of equipment out there that we're never going to see in a Google building that somebody might want to use this for. Those can either be contributed or can be extended locally, right?
Yeah.
It's very easy to just add new namespaces or add new entities to the model for things that, that are relevant to your individual use case.
And hopefully people will contribute. If you're listening to this and you're going to add your own, why don't you just contribute? So second question, like follow up to that is, now we have the Google Digital Buildings Ontology, we have Haystack and Brick, and we have the other ones. How do we as an industry get converged at some point? And is that in the cards?
It is. Preach on it, Keith.
So fundamentally, and if my teammate was here, he would be very adamant about this, is there are open standards for interoperability that are applicable in this domain. So RDF being the most obvious one. And all of these things can and should be cross-mappable, between each other. So that's kind of the first step is if you have a Haystack model, it is possible to make a transformation that makes it a brick model or a digital buildings model for the most part, right? I think each one of these different ontologies is natively good at different things. And so it isn't necessarily the case that you need to use one for everything, right? Because they are cross-mappable. You could imagine that in the future, all of the tools are, RDF compliant, let's say. So everything's natively using RDF as this model of the data. And you use digital buildings because digital buildings is a really easy way to rigorously configure your model, right? And then you spit out some RDF and then the tools use it. Or maybe you want to use, say, SkySpark or something, right? And so you can then go through RDF to Haystack, and now whatever tooling you get natively on SkySpark you can use. And, you could think of a bunch of other use cases. So while convergence would be great, we have one thing that rules them all. Practically speaking, probably none of these things are really ever going to go away, but we definitely can interoperate and should interoperate so that we have tools that can deal with all of the things.
Got it. All right. I like that answer. So what is the thing that would be like the universal translator in the future? I'm just imagining something that says, well, I can talk to Google and I can talk to Haystack and I can talk to Brick, right? Is that how it would work, or is it some other implementation? Is it like the middleman of the middleware?
So RDF is, if you think about it in terms of language, it's like the, the IPA, International Phonetic Alphabet. I think I'm getting that right. Like RDF is that kind of master set of primitives that allows you to represent anything. And so that's ultimately, something that has to work with everything needs to be able to understand that set of primitives. And then you can represent all of these different models with those primitives.
I see.
But in terms of the interoperability, to use language as a concrete example, native people who live in snowy places have lots of words for snow, right? Because it's something that they know a lot about, and there's no way to like literally translate all 22 words for snow into English because we don't have that concept, right? And so there is always going to be some kind of manual interpretation between, your model in Haystack and your model in digital buildings or Brick or whatever, because the concepts will not always 100% map one-to-one.
I found that every good ontology nerd has all of these analogies just in their back pocket in case they need them. And I love that. Yeah, and Corey will love that too when he's listening to this. Shout out to Corey and all his analogies as well. Cool. So what's the status of the project, right? So I'm sure people are reaching out to you all the time. First of all, like, why didn't you use Haystack or why didn't you use Brick? Like, they're reaching out about that, but then what are you guys getting from the community as far as contributions and that sort of thing with the project right now?
I would say for the most part from the community, from what I've seen, is questions about concrete utilization. Because like I said, one of the things that we don't actively support right now is like tooling that makes application of the model very express or easy to interpret. I think that's one of the shortcomings that we're still kind of dealing with. Okay. Like, we believe the model is very good, but that it still requires a little bit of tooling to make it to the point where like the lowest common denominator of user can effectively take it and run with it. Some of the comments that I've been seeing are just trying to understand some of our core concepts. I don't know, Keith, what would you say?
So definitely seen some interest from the other ontology purveyors in terms of, sort of seeing which concepts that we focused on that were different. And I think that that's been interesting. And there's also Brian Turner in Buildings IoT has been actually working on kind of a universal translator. So that's been sort of neat. So his shop, I think, is very heavily invested in Haystack. And his company also does a fair amount of work for Google. And so he's been sort of trying to figure out the tooling that does this cross-interpretation. So that's been pretty interesting.
Got it. I didn't know that that's what Brian's project was before I asked that earlier question. So good to know. Okay, very good. All right, so a couple more minutes left here as we kind of close things out. I want to head away from that. So if you have anything else to say about the project, let me know. So one of the main things that we haven't quite hit on is you mentioned supervisory control and you mentioned visualization of the data. We've mentioned FDD. Are those the main sort of applications that you guys are developing today? And specifically, Trevor, I want to ask you something I heard from Jeremy the other day, who's one of your coworkers. I was in a meeting with him, and he said something along the lines of FDD specifically, you guys have a little bit of a different philosophy around it and how it's not a product. And I don't know what it is if it's not a product. So can you kind of explain that and how you guys are implementing analytics in FDD once you do get the data modeled properly?
In my mind, FDD is physics, pure and simple, and you can't put a patent on physics. And so like you can come up with a fancy way of doing a valve fault detection or doing some whatever you want to do, right? But like anyone with a core understanding of first principles should be able to replicate it. Mm-hmm. And I hate the idea, similar to what we were talking about earlier with, somebody making a career out of mapping data when a machine should be doing it. Mm-hmm. I feel like a lot of these things that we're doing in FDD, I happily give all the FDD that we're working on to our clients and even sometimes to our competitors, because like, that's not where the value is. I can detect for you anything that you want to detect. Mm-hmm. And frankly, you can too. The thing that my company specifically is trying to provide as part of the value is utilization of that insight and action, which is always the hardest part. Like I remember at Microsoft when we started back in 2012, we were flagging 5,000 faults a day across 100 buildings, like far too many for anyone to actually action, because like you maybe hit 5 or 10 faults a week if you're good. And so what was the purpose of detecting all that other stuff? So in my mind, fault detection is somewhat of a red herring because everyone thinks that this is the big be all end all, but 90% of it probably isn't because it's detecting things you don't care about. And number two, it's fairly easy to detect. Like even the advanced stuff. And I know that people out there are going to argue with me about like, oh, but you're not doing it this cool way or whatever. Well, I don't believe that the value proposition for people that use fault detection is in the creation of the fault detection.
Yeah, there's going to be some people that are reaching out. I'll tell you that. So go ahead, Keith. Yeah.
Well, I was going to say to jump on that, and one of our ML engineers open sourced the project that obsoleted a bunch of our FDD rules fairly recently. So we actually built a tool, and this is a great example of like why standardization matters, right? So we built an ML engine that took the standardized data and then without any labeling, so this is unsupervised ML, was able to pick out anomalous devices and, rank them by how anomalous they were, and also attempt to attribute to which points were likely responsible for the anomalousness, and basically covered all of the manual FDD rules for the piece of equipment we tried it on with this one model. And so we now have in our operations center just this one dashboard that just pulls up these anomalies, ranked by severity. And that has completely changed the way that they deal with that whole area. And the nice thing about it, as Trevor was saying, is it first of all doesn't give you anything that's not anomalous, right? And so already you've brought down the number of things that you have to look at a whole lot. And then you can very easily just turn the knob on, like, how bad do they have to be before you show me? And you can bring that number now down to a number that's actionable. And so your facilities operators are happy, and you end up dealing with the things that are actually the most problematic.
So this is a different perspective on FDD that I'm used to. So I have two questions on it. One is, you mentioned like getting to a root point or a root sensor that's causing the anomaly. But what I'm not hearing is, how do you, in that approach, so my opinion on FDD software is that the best FDD software, it does the best job of producing a root cause for you from the fault, right? So the worst FDD software says, hey, I have like 5,000 faults, like you said, and I don't know what you should do about it. Someone should probably go out to the field and check out all 5,000 of those, and hopefully you can figure out what the highest value root cause is. The best ones, though, they say, okay, here's your one, right? And here's your one, and I've ranked it by whatever metric you want to rank it by. I've ranked it by annual savings. I've ranked it by the impact it has on the most amount of people, those sorts of metrics. So the reason I think it's a product is because I can do all this in Excel by going out to the building, like we talked about, Trevor. Like, we used to do this without the software. So it's doable, but the product is what's automating all of that. And the product, to me, is what is just a huge difference between what I can do with Excel versus what I can do with the best FDD software out there.
Absolutely, absolutely. And don't take me the wrong way. I'm not saying that FDD platforms, aren't of value in and of themselves, because I think they are if you configure them right. I just don't like the idea. I was talking with one manufacturer the other day, and I was asking him, oh, what kind of fault rules do you have? And it's like, oh, we have a whole library of proprietary fault rules. And it's like, can I see them? Are they any good?
Totally.
We'll get you on the NDA, and then we'll be able to send you some of this back information. It's like, screw that. I can rewrite all of these. I'll just get them out of an Excel file from 2015.
I love that. Yeah. I had this client a couple of years ago, and it was with one of the big four, and one of the big four was doing FDD. And what we were trying to do, and I've told this on one of my Friendly Rant episodes, we were trying to figure out what the existing rules did so that we could just program new ones to supplement them. That's all we were trying to do. And we had to go through a lawsuit to get these existing rules. And it was just like the easiest, like basically the NIST air handler rules is what we were asking for, right? And what we got back was, you're going to have to sign an NDA, and anyone who sees this like spreadsheet with these rules is going to have to like sign their life away. I totally agree with you. It's crazy out there. It's not proprietary.
People treat this like it's proprietary. And frankly, I would love to start an online repo, maybe as part of this project, if we ever get there, Keith, of all the different FDD that's available, and just have it, use it. I mean, you're still going to have people out there that are rock stars and that can help you to utilize it and take advantage of it. And there's still going to be people out there that kind of suck with it. And I mean, that's always the state of every industry. I think my goal would be to see all boats rise as this technology advances, and the idea of these little pockets of like proprietary knowledge is being orthogonal to that motivation.
Mm-hmm. Brilliant.
Rant done.
I love the rants. So I guess my last question is around, I don't know that I'm fully grasping the scale here, right? So tell me about like lessons you've learned around doing this at such scale, and what would I not understand about that?
Keith, you want to take the first stab? Maybe I'll take the second stab.
Well, so I guess I'm going to sort of skirt the question in some ways and say, one of the things that we haven't had to worry about is actually the scaling of the infrastructure that runs this stuff. And that's been really great because effectively what we've done is pushed all of this up through, various cloud technologies. Obviously there are cloud technologies because we're an internal Google team, but like the fact that we have, Bigtable, and that we have IoT Core, and that we have Apache Beam, basically make the infrastructure part of this trivial. You could do this for a massive, massive fleet of buildings, sending you data all the time, and like it just scales horizontally forever. The hard part is the part that we make Trevor do, which is actually getting the data, cleaned up from all these buildings and getting the coverage of all the equipment.
Yeah. So the initial modeling of the core concepts that we can use, replicate them from place to place, like novel concept requires some deliberation about how you might model them, which is kind of the hard part for this. And it doesn't exist for the other ontologies because I think they just sort of sidestep the issue. It's a, choose your own adventure kind of thing. And we fundamentally don't want ours to be like that.
Okay.
But then the second piece is like, how do I rinse, lather, repeat, take like a spreadsheet or an initial discovery from a backend device and convert it. And so I've piloted some software that I wrote that hopefully Keith and his team will be taking and running with from a workflow perspective that we'll be able to add to our open source project to help aid the exploration of the ontology. Like, say that I got this device with a set of fields. I'd love to be able to just ask an application, hey, give me the thing in the model that is closest mapped to this. So like we've got some software that currently does that, but like it needs to get added to the platform. And so I would say that that's probably the piece that certainly we have not solved yet, but we're going to be focusing on it and trying to solve at least a piece of it. And that I also don't think anyone else in the industry has bothered to grapple with for reasons that we've kind of already discussed.
Okay.
I mean, yeah, that's the first hurdle. If you can get through that, if you can get through that integration layer, like Keith's platform does, quality assessments of data that come through. And most good platforms do this. I've worked with clients that have built their own, and obviously in Google, but also in Azure. I've worked with clients that have done this using third-party softwares. And frankly, we're not like for Google specifically, like, yeah, we use that. But from my perspective as an outside consultant, I don't really care what people use as long as they follow some of these core principles.
So last question, I always do this where I say it's the last one and then I come up with another one. Sorry. Google's building a new building tomorrow, right? And it's in some country. How do you guys enforce this? So like if I'm an organization listening to this and I'm going to build a new building tomorrow and I want to use this, how do you guys make the contractors and make the output of a new building meet the standard?
Required in the contract? Actually, I'm not kidding about that. So there's the requirements part, which is literally like you put it in the contract. And then there's the making it feasible for them to do it part. And the second part's a lot harder.
Yeah.
So conceptually, the goal is to bring the model information as high up the design stack as possible. Because what we've found, and basically, so you think about the evolution of this. We started with nothing, and then like we started building this ontology, and now all of a sudden we have this thing that we want to implement in buildings, but these buildings have already been in construction, and we're like, okay, we want to tack this on at the end.
Yeah.
And what we've learned basically is that the closer and closer you get to FDOB, the less time people have and the more stressful it is and the harder it is to do anything. And so what we've learned as we're doing this is the more mature we get, the farther up the design stack we bring this stuff. Mm-hmm. And so the ultimate goal is that when you have your mechanical designer doing something in BIM, they can say, okay, I'm putting in this piece of mechanical equipment or this piece of fire system or whatever. I can select in my BIM plugin which type from the ontology it is. Okay. And now the information on like what fields are required to be mapped, just kind of comes out of the design process, and you could just hand it to your integrator and say like, this is what it needs to look like. And so that's what we're trying to get to. But right now we're kind of in that intermediate stage where like we've now gotten the MSIs on board early in the process of commissioning, but we're not so mature yet that we can literally just design the building with this built in.
Got it. Yeah. And I would imagine like there's still this aspect of, just like we're commissioning an actual building system, we then need to still commission the digital side of it as well. Like, so is there a lot that pops up around enforcing it after the fact? Because I can just picture a contractor being like, it's done.
Yeah, Trevor said it earlier. No human should do this. And we do have automation that basically we require that they give us what we call building config. So it's a YAML configuration that tells us all about what equipment's there, what its relationships are, what types they are, et cetera. We ingest that, we validate it, we make sure it's self-consistent, and then we actually will validate the telemetry coming up to the cloud to make sure that it matches the model automatically, and then just hand you your error report, please go fix.
Got it.
Yeah, assuming that you can train them in how to apply and build the building config model, we have tooling in place to confirm that it's correct.
Got it.
And like I've said, one of the things that we want to kind of extend this to is, number one, up the design stack. So getting into BIM and into the design phase earlier. But number two, like, creating this model after the BMS has already been implemented is still going to be kind of a common business as usual process. And so making it easier for an MSI with minimal training and with their current workflows, working with spreadsheets or whatever it is that they do, how do we make it so that that process sucks the least that it can?
Yeah. And, one other thing that was really interesting that I didn't even think of initially with this modeling stuff, which is that when you define a model, you're making some statements about actually how you want something to be built. And what we found is that we do actually have strong opinions about how we want things to be built, in mechanical systems, and as an example, that weren't really getting followed in practice. And when you have a model with sort of some pre-made entities that represent your expectations, you can actually catch these design anomalies early on because your designer says, hi, there's nothing in your model to represent this thing that I want to make. And then we say, no, don't make that thing.
Don't do that.
Make this other thing that follows our standards. And so that was really interesting. That I didn't even think about that when we started doing this whole modeling exercise. And then we found this one building that we built where, it was not at all to how we expected, the mechanical system to be built. And we're like, oh, if we had just given them the model earlier, we would have caught this and not had a building that was weird, right?
That's fascinating. So I've been preaching the power of like control standards, which include profiles and pieces of equipment and points lists for those profiles, and then obviously the data model on top of that. But when the data model already includes those things, you can just start with the data model. That's really interesting.
Yeah, and just to give a concrete understanding of what was happening there, we were seeing on these brand new buildings pressure dependent VAVs being specified without PID control or anything like that, and it was just like,
don't do that.
Why would you do this for a brand new construction? Like that was the sort of stuff where it's like, if I saw a dual duct VAV,
that is not in our model.
Like, do I want to extend the model or do I want to just shame them?
Yeah.
I'm sure somebody, again, like, I've done some mechanical design and stuff like that. I'm sure that somebody out there has a great,
great reason for pressure dependent VAV boxes. I'm not sure about that. Yeah, I'm not sure about that. Okay. Anyway, that's a wrap. Thanks so much, guys, for coming on the show. We'll have to do another to get an update sometime, but thanks for doing what you do.
Yeah, thanks for having me. It's been fun.
Thank you.
All right, friends. Thanks for listening to this episode of the Nexus podcast. For more episodes like this and to get the weekly Nexus newsletter, please subscribe at nexus.substack.com. You can find show notes for this conversation there as well. As always, please reach out on LinkedIn with any thoughts on this episode. I'd love to hear from you. Have a great day.